Hi everyone, I hope you're okay, and I really hope that guys the videos will keep uploading or helping you out. This is the last video, guys. So if this is the first video you come across, please note that there are 8 videos before this one, whereby I'm tackling the 2023 November physical science paper 2. You can just download the question paper and do the questions with me. Just click the link on the description below. It will take you straight to the playlist whereby you can see the videos from question 1 up until the last question, this one. Okay, before you even start, guys, please don't forget to subscribe. Your subscriptions will help us to grow the channel. Okay, question 9. An electrolytic cell is set up to purify a piece of copper that contains silver and zinc as impurities. A simplified diagram of the cell is shown below. Electrode R is the impure copper. Okay, so what's happening here is that this electrolytic cell is set up to purify the impure copper that is here. Are you together? So all of the time whenever you purify metals in electrochemistry, the metal that you are purifying, it will always be at the anode. Are you together? So electrode R will always be your anode. That means electrode Q will be your cathode. Are we together? Excuse me. Okay, now let's answer the question. Question 9.1. Define the term electrolysis. Electrolysis is a chemical process whereby electrical energy is being converted to chemical energy. Okay, and then 9.2, we are supposed to write down the half reaction that takes place at electrode Q. Remember, guys, they are purifying copper. Are you together? So the only half reaction we're going to be concerned about is the one for copper. Is the one for copper, right? So this is the only half reaction we're going to be concerned about. It's copper 2 plus excuse me, plus 2 electrons, giving us copper solid. So here I will have copper 2 plus 2 electrons. This will give us copper as a solid, right? But at the anode you'll simply have copper, and copper will become copper 2 plus because it will give away 2 electrons. Right, together. So the half reaction that is taking place at electrode Q, we can simply write copper 2 plus will receive 2 electrons for it to become pure copper. Okay, and then now we're being asked, in which direction do the electrons flow in the external circuits? Choose Q to R or R to Q. Always the time, guys, electrons will flow from anode to cathode. Are you together? We did specify that electrode R is our anode and electrode Q is our cathode. So the flow of electrons go from R to Q. Okay, and then now we are being asked to calculate the current needed to form 16 grams of copper when the cell operates for 5 hours. Okay, I want to know how much current will I need for me to form 16 grams of copper, right? But for me to find the current, I must be able to know the electronic charge that will be transferred. Are you together? For me to know the electronic charge, I must be able to know the number of electrons which are transferred. Are you together? And for me to find the number of electrons which are transferred, I must know the number of moles of my electrons which has been transferred. So how can I do that? Okay, since I'm told that only 16 grams of copper will be formed in 5 hours, I know that I can calculate the number of moles for copper. The number of moles is simply mass all over the molar mass, right? They only formed 16 grams. the the molar mass for copper it's there in the periodic table, is equal to 63.5 grams per mole. Whenever I divide this excuse me, whenever I divide this, whenever I punch this on my calculator, 63.5, I'll simply get 0.2520, 0.2520 moles. Alright, together. And then these are the number of moles of my copper which was formed, right? But I know that according to the half reaction, I have copper 2 plus, and copper 2 plus will need 2 electrons to give me copper solid, right? Now I simply know that I only need 2 electrons to form my copper. I want to know that if ever I form 0.250 moles of copper, how much of the electrons will I need? So I'll just cross multiply here. Then X, which represents the number of moles of electrons, will be equal to 2 times this thing. This will give me 0.504 moles. Now I know the number of moles of the electrons which are transferred. I can then go and find the actual number of electrons which are transferred. How can I do that? I know that number of electrons, the number of moles of electrons is equal to the actual number of electrons all over the Avogadro's constant. Are we together? So for me to find the number of electrons, I simply need to say the number of moles multiplied by the Avogadro's constant. The number of moles is 0.504. The Avogadro's constant is given there as a constant. It's 6.02 times 10 to the power 23. 6.02 times 10 to the power 23. So this will give me the actual number of electrons, 0.504 multiplied by 6.02 times 10 to the power 23. Okay, this will give me 3.03408 times 10 to the power 23 electrons. So these are the number of electrons which were transferred to form copper, or rather to purify copper. Alright, together. So now I know the number of electrons. I can go and find the actual charge which was transferred. The actual charge which was transferred. I can continue here. Let me write in green. How can I find the charge? Charge is always equal to number of electrons. Okay, for me to find the charge, this thing is given to me at the formula sheet, right? The charge is okay. Let me just substitute. I do have the number of electrons, right? Number of electrons is simply 3.03408 times 10 to the power 23 is equal to the charge all over 1.6 times 10 to the power negative 19. So therefore the charge 1.6 times 10 to the power negative 19 so the charge that I'll get is 48,545.28 coulombs. Remember that for me to find current is always the rate at which the rate of flow of charge, right? So my current will be just the charge all over the change in time. The charge is 48,554.28 divided by the time. I was given the time in hours, right? And I must always convert my time to be in seconds. To change the given time in hours, I must multiply the whatever hours I was given with 3,600 for me to get the current. So I'll just divide this by 5 multiplied by 3,600. This will give me 2.7 amperes as my current. So 2.7 amperes of current was needed to form 16 grams of copper. Okay, let's go step by step, guys. Now, firstly, I wanted to find the number of moles of the copper which was formed. That's the first thing I did. Né? And then secondly, I calculated the number of moles of the electrons which were transferred for me to form 16 grams of copper. And then thirdly, I calculated the actual number of electrons which were transferred to form the 16 grams of copper. And then step number 4, I calculated the electronic charge which was actually transferred to form the 16 grams of copper. So that's number 4. And then finally, I then calculated the current that was needed to form the 16 grams of copper. That's how guys you would have tackled that question. Okay, 9.5, we are told that this electrolysis or during this electrolysis only copper and zinc are oxidized. Give a reason why silver is not oxidized. Okay, we'll go and check their reducing abilities. Only copper and zinc are oxidized, but silver was not. Okay, where can I find silver? There is silver. Where can I find zinc? Zinc is there. Okay, we can see that zinc is the standard potential for zinc is more positive than the one for copper, and no, the standard potential for silver rather is more positive than the one for copper and zinc. Are you together? Which simply means that silver has a greater strength of being an oxidizing agent than it has a greater strength of being a reducing agent. Are you together? So in this case, only zinc and copper have the reducing ability, which is more than the one of silver. So that's why only copper and zinc are the ones which are oxidized, and silver was not oxidized. Why? Because silver does not have a greater reducing ability. I hope that makes sense, guys. If there are things I'm not sure about, guys, please make sure that you do ask on the comment section, and please note that there are other memorandums for mathematics. I think there's more content even for mathematics, whereby I teach things from basics. You can just indulge, guys, and hopefully you learn a thing or two. Thank you very much.